Hello everyone and welcome back to another video. Today we're going to be covering the tuning of the Hyundai I30N with the SIM2K-250 Control Unit. So I'm going to be going over pretty much everything for a stage one with the emissions turned off. This is for a race car, okay? Yeah, so we're going to go through it all. It's a car from Romania. I've been given some instructions about how this customer of mine would like the car tuned, so we're going to be going over all of that together. He sent me a file package of the logs, I'm assuming the dyno graph, and also the calibration factory file of this car. Okay, this is the car. This is the one we're going to be working with in Romania. Very, very cool. And yeah, so let's pretty much get started straight away. If we go into the desktop, putting that file in there, and then bringing it in. Let's have a look. Next, what I'm going to do, I'm actually going to go pretty much from nothing. So I'm not going to import any data from any of the other files that I've worked with before. We're going to pretty much start from nothing here. Okay, we're going to start from nothing. So it's a Hyundai I30N. Okay, it's PD. It's PDE or something like that they call it. And this is Romania. Perfect. Okay, we're working with this. Right, let's get straight into this. So with the with this particular software version, that is it there. WinOLS has actually found it for us. The way that it does that, it actually goes through the file and it looks for the ASCII sequence of characters where there might be an identification string. And that's what we have here. Yeah, as you can see, we've got the PDE and then followed by the calibration number there. Okay, each individual box code or calibration number can be different for region. They can even be different for the same car, the same year, even with the same gearbox. So usually it's adjustments to emission standards or drivability improvements, things like that. Okay, if there's glitches or errors in one of the software versions, then they go ahead and they change all that. SIM2K-250, we're going to work backwards from our demos here. Okay, this is our definition file, and we're pretty much going to start by defining all of the maps in it together. So what I always like to do when doing these sorts of files is start with something like the Lambda. Okay, so we're going to go through all of the Lambda maps, which is our pretty much what ends up being our AFR and things like that. So we're going and highlighting a section in the right file and searching for it in the left and finding where they're similar. This means we can transfer the map structure from our demos or our map pack and create our own map pack with it. So I'm transferring all the maps here, and as you can see now, the map definition has been transferred from one software version, which is from the Veloster N facelift, to the I30N pre-facelift over here. Okay, and as you can see, it automatically finds the axes for us and then gives us the offsets and everything for the map here, because we've actually removed it off from the right hand side. So we're going to go and do that for all the different Lambda maps so that we can essentially start to control the fueling correctly for this car. Okay, I don't believe with a stage one we need to change anything to do with the fuel pressures, low pressure or high pressure fuel pump for this particular car. It is just entirely Lambda set points and maybe some injection timing. It just depends on the car and the fuel quality, all those sorts of things. Lambda for full load enrichment, so that's obviously when you're in full load, usually determined by a particular amount of torque or boost or filling. And then once you hit that sort of point, then the ECU determines that you're at a full load state, which is wide open throttle, you know, pedal to the metal, and it has a Lambda enrichment target depending on that condition. We're going to have our reference Lambda table here. Cool beans. You've got Lambda load enrichment, full load enrichment for sport mode and things like that, but these are actually appear to be disabled from factory. Okay, these don't actually do anything, or at least not in this particular calibration. While we're here, I may as well start transferring a few other maps, given that they're right here. It would make sense for me to do so. Some things that we're going to need, or at least reference, so I can explain a little bit more about the strategy. A lot of this I didn't need, so I'm going to delete the things that I did not need. going back down here. Let's have a look. Delete all this. I don't need any of that right now anyway, and plus I'd like to keep it simple so I can explain it. Cool. Then we've got our reference indicated engine torque maps. Like I said, just because we're in the data area where those maps are, I'm just going to transfer them anyway. I may as well. It would make sense to do so. All right, with the lambda tables, we've got our basic lambda set point, reference lambda, lambda for full load enrichment. I believe there may be one based on some particular exhaust gas temperature conditions, basic lambda for engine exhaust gas temperature model. So that might be something that we also want to transfer. There we go. Okay, there it is. Yes. Okay, so we've got that over it as well. And I think that's pretty much all we're going to need for now. I don't think we're going to need anything else in terms of our lambda target. What we might now do is actually put all those particular maps in their own folder so that we know that they're all relating to lambda. So I go fueling, lambda, okay? And then they've got their own folder, and I'm going to delete all of the folders that now don't have anything in them. So we've got that all sorted out there. Now what we can do, indicated engine torque at reference conditions, we can put all them in a single folder as well and go torque model ref indicated, okay? And then we go torque model mass airflow, okay? So they're in their own folders as well, okay? Cool. Now let's go to maybe something like our base ignition. It might also be called basic ignition depending on the car and the software version and whatnot. And there we go, how it's defined. I'm going to try and find similarities between the left and right hand sides. Okay, we've got here, as you can see, the ignition tables are different between the facelift and the pre-facelift. That's because the turbocharger is different, so it would make sense that they are different in terms of the ignition angles. We have ignition correction based on temperature, all these sorts of things. These are definitely things that we're going to want to transfer across. We've got our minimum ignition, so this is our minimum ignition angle, right? And that is important to calibrate if we're going to, let's say, tuning crackles and things like that, although this ECU has something called impulse combustion. Impulse combustion is a function that allows the tuner, the calibrator, to essentially tune in crackles intentionally, and it's got logic for that will allow it to crackle in certain conditions, and that's obviously just for sound, right? That's what it's for. It's not really for anything else. I guess you could have the anti-lag aspect of it, but that's not really so much the main thing here. So just going through, we've got our minimum ignition, so ignition minimum. I'm just renaming that folder, like I said, so it's all very easy for us to understand. We've got our base ignition. We've got our reference ignition somewhere here. I am not sure where that went. Let's have a look through. What's this here? We have our reference ignition yet. So if I go in and maybe type, that's why. Okay, I'm going to actually undo that because that was the map pack and I don't need to change that. There we go. All right. So ignition base. Okay. I did not. How's that for like a Windows XP experience right there, opening all the maps? All right. Ignition minimum. And then we're going to move the reference ignition angles into their own folder as well. Move into new folder, ignition. You can do this optimum or reference. It doesn't really matter as long as you know what it is. That's basically the maximum amount of ignition timing the car will make, or it will allow it to make. And that's usually used in some model to calculate the optimum amount of torque for the optimum amount of ignition angle. So it'll usually say, depending on port flap position, depending on camshaft position, you'll have an optimum ignition angle, which will create the most amount of torque. So it's like maximum brake torque, essentially. And that's what the reference ignition or the optimum ignition tables are for, okay? Another Windows XP experience there. Okay. Let's go ignition correction. Let's do temp correction. Okay, so now we've got a little bit of a map pack going on the left-hand side. That's pretty good. Now we've got the fueling, we've got some of the torque model, we've got the ignition timing. I'm now going to look at impulse combustion, which is our crackles in depending on driving mode. So I'm going to transfer a few of these across now. Okay, luckily for us, it's quite similar between the two software versions on the left and right hand side. Okay, cool. I'm going through all of these. I know I work very quickly. It's a bit hard to sort of keep up, but it doesn't really. Okay, there's a lot of good things for us here. All right, so there's a few different configuration bytes and everything going through all this. Okay, let's have a look. Cool, that all matches up. Let's have a look at this. That's there. Let's have a look at this. That's there. Convert or transfer rather, all that across. Fantastic. Now we're going to go for the activation times for our impulse combustion modes. Here we go. Yep. Transfer all that across. Yes. Fantastic. Okay, that's pretty much what we need. So that's our impulse combustion, which is, like I said, the crackles in sport and all that sort of stuff. So we can now delete that. I might actually make it an ignition folder for that. Ignition impulse combustion, just for completeness. Okay. Cool, impulse combustion. Boom. There we go. So we've got the map pack on the left that we're creating. Fantastic. And let's say we want to go through our torque maps now. So torque max is what we can type in the filter and go through the definition file, the Damos or the map pack, to try and find all of the relevant maps that we need to start calibrating this. Okay, so we're going to look for our torque limits, we're going to look for our torque monitoring, all these sorts of things, and basically eventually go ahead and start tuning them, right? So let's see if there's any similarities here. Okay, so I'm going to just scroll up, let's have a look. Boom, there we go. Matched up maximum torque for gear ratio. That's all already maximized. Can't really get a higher value than that. And then we have our maximum torque depending on coolant and oil temperature. Let's have a look. What else do we have? Our maximum indicated engine torque to prohibit pre-ignition depending on intake air temperature. I'm going to transfer that across as well. There it is. Yes. Fantastic. So that's great. So I've got all that. That's all fantastic. There's a few more. Yep. So there's some torque limitation function depending on turbocharger speed, which is modeled in this ECU. There isn't a turbo speed sensor for this car. So it's all based on a model. Maximum engine torque requested by gas pedal for brake and the limitation. So that essentially will allow us or not allow us to brake boost. Okay, there are quite a few other little maps here. Torque limitation for driver request for gear shifts, all this sort of stuff. This might be good for us to have. We'll go transfer all that sort of stuff as well. Okay, torque threshold for increasing torque for race start. Some pretty cool functions here that we can play around with for our launch control. Let's have a look. What else can we get? Okay. Basic torque offset depending on cat heating. All this sort of stuff here. Alright, I'm going to transfer all this. Cool. Let's have a look. Torque. That's looking pretty good at the moment. Going through all the different file folders. Okay, torque limit. There we go. So now we're looking through all torque limit maps. I think we've got all those already. What I might do is start transferring the torque limitation maps depending on turbocharger speed set point. Start transferring them across. Transfer, fantastic. That transferred all those across. Increment of torque limitation for turbo speed protection, transfer them. Okay, funnily enough, we're in the area for the pressure up throttle set point. That's our boost pressure target. We'll transfer them. Okay, let's have a look and see what else we need here. Factor engine torque limitation, so we can basically, based on limp mode, we can actually create, I suppose, an offset or a multiplier that is applied to maximum torque to reduce maximum torque during limp mode. So when it's limp mode, there'll be a factor of 0.75 applied to the maximum torque limit to reduce torque during limp. So there's things like that we can calibrate. I mean, it's incredible. When you have files like this, you can calibrate all sorts of things, like from the air compressor torque to turbocharger speed to exhaust gas temperature model, and then injection angle, everything. Everything the ECU controls, it is completely and fully calibratable, which is pretty cool. All right, so I might now get into our maximum air limits, okay? So this is usually a mass airflow limit that the ECU has. I'm just basically going to try and find where that is. So we've got it here. Okay, maximum intake air, which is in milligrams per stroke. That's being transferred across. Going through and looking at what else we might need. Maximum air charge quotient for air pressure too high. That's good. So that'll be like a boost ceiling. Pressure upstream throttle for threshold for intake overpressure protection. We've got that as well. Keep going. We've got that already. Maximum allowed air set point in the cylinder. Transfer that across. I know there's another map which has to do with pressure in cylinder. That is also going to be transferred across. See, it takes a lot of time to sort of remember what maps are required for this sort of thing, right? There is a lot that goes into a tune, and it takes years. I've been doing this now for 8 and a bit years. So to know everything that's required to change can be pretty crazy sometimes to try and go through it all. All right, so we've got our map boost pressure actuator set point. Gonna need all that, of course. Okay, a lot of different things here that we're gonna need. Open loop wastegate control signal. We're gonna need that as well to control the wastegate when it's open loop before the closed loop PID starts to correct how that operates. I think we've already got that map. Yes, we do. Calculated turbocharger speed. Okay, cool. Ambient pressure-based maximum turbocharger speed. Customer specific turbocharger speed maximum. These are all functions to limit the speed of the turbocharger, which will have an effect on maximum boost and resulting torque. Pressure ratio at the turbocharger for upstream throttle calculation, that will change when we start calibrating the car. Air pressure drop at the intercooler. If you upgrade your intercooler, there will be a different air pressure drop than factory. This is what the factory intercooler creates in terms of air pressure drop on usually intake air volume, kilograms per hour, and then our pressure inside the intercooler. Bigger the intercooler, usually less of pressure drop, but you can use this to artificially inflate the request. Don't recommend doing that, of course, but there are a lot of different things that you can do. Okay. That's good. Going through a few of the other maps to do with the turbocharger control. Map for boost position set point for the actuator. Okay, all these sorts of things. That's good. Right, maybe do we have max boost? Start looking at these sorts of maps. Open all folders. Go through this. Maximum boost pressure. Set point for the actuator. Usually it's pretty much, yeah, that's fine. 75%. Let's have a look at that. Cool. Okay. We've got that now. We can also have a look at the throttle plate. Throttle max. Okay, because usually the throttle plate is limited in a lot of cars, and we can actually change the maximum throttle angle that can open. So it's 85 degrees. We can change that to 87. Usually that translates to another 4 or 5 horsepower. So that's just something else that we can do. And there is a single limit as well that we need to calibrate. Upper limit of the throttle. Got a few things here. I probably should start working on the map pack in this software version we're working with. I haven't really put it together yet, but I'll just keep going. Let's see, torque, offset. Do we have any of these maps in this? I'm pretty sure we do. No, torque monitoring maybe. Monitor. Indicated engine torque at reference conditions. Yeah, we'll need that. Okay, so I'm using control and the arrow keys to move around the hex dump like that. Cool. Maximum reference indicated engine torque, we've got that. That's good. All right. Very, very nice. Now we can probably start looking at the CAT diagnosis things, and also the GPF, CAT efficiency. Here we go. So manual deactivation for the catalytic efficiency diagnosis. Let's see if there is any similarities here. There definitely is. Yep. So calibration flag to force catalytic efficiency diagnosis to be inhibited. That's something that we're going to want. Okay, and usually there's also a set of maps for the mass airflow range in which there will be monitoring of the CAT. See, minimum and maximum mass airflow for catalytic diagnosis activation. There are some of the maps that we're going to want to calibrate as well. GPF, diag, I don't know if it's going to be as easy as that. There we go. Minimum time. Let's see if this particulate filter maps are that easy for us to find and calibrate in the software version to my left. So this is another thing, right? As you start looking at certain parts of the file, there are differences, as you can see, right? Like it's not going to be the same between different software versions. Often software versions will have additional like a logic in there that isn't a part of some other ones, right? So we're going to have to work through this and figure out where we're going. So let's see if this is a map in our left. No, it's not. Is that going to be something that's found? Yes, it is. Okay. See, basic switch to enable particulate filter active regeneration function. So that's something we want. Enable particulate filter regeneration while driving. All these regeneration. We want them so we can calibrate our GPF. Okay, I'm going to transfer all those. Okay, there is a little bit of a difference there. Okay, so we've got volume of the particulate filter. Running time threshold to request the particulate filter regeneration. Things like that, we're going to need all that in there. Let's see if this map exists in here. I did not mean to do that. Okay, they're connected now. There we go, that maps that one there. So what you're looking for is just where they match between the left and right hand software versions, right? So let's say 13412, is that in the left one? No, it's not. 412, is that in there? It's probably not going to take us anywhere where we want to be. Cool. All right, let's have a look. OPF, is that something that's in this? No, it's not. P-filter, which is particulate filter. No, it's not. How do they, so what do they call it in this? PF. It's not P-filter, it's PF, particulate filter. Let's have a look. Block filter diagnosis, missing particulate filter detection. I'm probably going to connect the windows before I start looking for these. I think we've got all that. We got all these too. Yeah, we've got all that. Max and minimum temperature thresholds for particulate filter. You know, there's just a lot of things on here that I can't be certain that that is what I'm looking at. But this looks like it's probably where we're going to want to be playing. Let's just say the software version on the right hand side doesn't have the particulate filter, but the one on the left does. That's why we're getting a difference, right? Let's have a look and see if that matches up. No, it doesn't. Does that match up? No, it doesn't. We might not need to use these maps if we've actually disabled it via some configuration byte. All right, so let's just go through and see. I think we might even have enough already for that. Sometimes in the variant coding, you can actually find CC configuration data to use GPF. It just depends though, this might not be something that we can find in this software version. In the variant code, you can also turn off the cats. There we go. Well, that's convenient, isn't it? Look at that. We've got our configuration data to use GPF. We can just turn it off with that byte there. That's pretty easy. Configuration for port flaps, powered steering, configuration for race start, so we can disable or enable it. All of this stuff. Gear information, TCU type. Wow. There is a lot here. Manual setting of vehicle speed limiter. Configuration for wiper, you know, model year information, all that sort of stuff. Let's have a look. EVAP diagnosis, fuel tank purge acquisition, all sorts of things here. So I'm just going through and having a look and seeing byte for immobilizer, immobilizer system, malfunction indication lamp, fan control, catalytic efficiency diagnosis, isn't that convenient? AC pressure signal, alternator type, all these sorts of things. Wow, there is so much here, isn't that fantastic? That's pretty good. By the way, guys, you're welcome to use the chat. I forgot to mention that. If you want to ask me targeted questions, I will answer them for you. So just use the chat in YouTube, and I will answer whatever questions you guys have when I look back at that screen. So just go ahead and fire some things through. I'd be more than happy to answer them if I can, or at least to the best of my ability. Got a few things now going on. So we've got our torque, we've got our boost, we've got our ignition timing, we've got our lambda, we've got our wastegate control, we've got our catalytic diagnosis and our GPF or gasoline particulate filter diagnosis. Just trying to think if there's anything else that I can think of that we need. I don't, look, if there is, we'll get back to it. I'm not gonna focus on it right now. One of the things I might also do is some of the software versions I've actually already gone ahead and I've actually created like a patch in the processor area which disables the catalytic monitoring, right? But let's go ahead and turn these off. How good's that, right? So that turns off the cat and that turns off the gasoline particulate filter in the variant coding. So it shouldn't theoretically use either of the maps for the cat, diagnosis, or the GPF, because this is like the overarching hierarchy whether or not it is installed in the car. So if it's not installed, it's not going to diagnose it. You can go ahead and tune the maps for it if you want to, if you feel like it's necessary. Like all this sort of stuff, you can go through and turn it off, you know, disabling it that way if you feel like that's so necessary. So I might just go ahead and do it anyway. Yeah, let's just turn all that off as an example. Okay, let's start off with revision 1, GPF, cat. What else has this customer asked for? Yeah, okay, Vmax, which is the vehicle max speed, stage 1. Okay, that's something that I actually do have to transfer from the Damos, is the max vehicle or vehicle limit, and then kilometers an hour, and see if we can find the maximum velocity. There it is. See if it gives us something that we can find between the two. Not going to worry about that for now. Okay, here we go. Written top speed limit, vehicle velocity, speed limit, miles per hour scale. Lovely. Threshold of vehicle speed limitation. There we go. That's one of the maps there. Maximum vehicle speed limiter, miles per hour scale again. Okay, that is good. So there are all our Vmax maps there. He didn't ask for the engine speed to be raised, so I'm going to leave that where it is. Okay, might go 400. There's absolutely no way this car's reaching 400 kilometers an hour. I would love to see that. What is that? 190, 400. Okay, I'm not going to touch that. Actually, I might set that back to the way it was. Maximum vehicle speed limit of 400. Cool. All right. Now we could probably start on... Actually, I do need to transfer 2 more maps, so I remember now. Max turbo speed. That also needs to be something we calibrate. There is 2 of those. Cool. That's all good. Okay. Wow. Okay. How many maps have we got here? We've probably got a lot if we close all that. They're all the different folders containing the maps that we need for tuning the car anyway. So we'll go through all this together. If we go to Lambda, okay, open all this up. Don't need to worry about it. GPF, okay, basic Lambda for engine operating, depending on the exhaust gas temperature model. Okay, we don't need to change that because it's for the EGT model. Okay, Lambda for interpolation on ignition angle with correction. Yeah, okay, let's go ahead and do this, right? So we've got, probably have our target enrichment around there. Going to do a little bit of that staircase movement, start off with 0.88. And for a stage 1, we're probably going to target a lambda of around 0.82. 82, maybe go 0.85 there, and then when we're kind of at full load, we'll go for 0.82 there. So it's something like that, okay? And that's what it's going to look like in 3D. If you want to do a bit of smoothing, you can. I mean, it's not going to hurt, right? Like, yeah, not going to hurt. And basic lambda set point. This map here, we might want to do something very similar if it's the same size, which it is not. But let's say if we go copy this in at 2000 RPM, 800. That did absolutely not work. 0.88. Okay. Might even do some interpolation, left and right. Interpolation, top and bottom. Make it a little bit nicer, left and right. Okay, and then maybe we want to go from 0.88 to 0.8685, and then we want to go 0.82. Look at it in 3D, make sure it's nice and pretty for us. Okay, just looking at that, am I happy with that? Yes, I would say I am. Cool. Saving it. Full load enrichment, okay. Irrespective of temperature, or maybe when it's pretty hot, you might want it to be quite rich. Just for protection, right? Usually. Let's go and do really anything over 120. We kind of want enrichment, right? Like, we'll probably leave the factory enrichment as it is. Otherwise, we'll calibrate the way that we want it, 0.88. Okay, and we might just go 0.82. Something like that, and then copy that into eco driving. Yeah, let's have it the same depending on whether it's eco or not. Reference lambda. Extrapolate the axes, let's go 1500, let's go 1250, let's go 800, and let's go 7000, interpolate between the two. Okay, and we've got 0.88, or maybe 0.86 at that point. We go 2500, 0.82. Cool. Alright, that's our lambda done. Throttle, yep, cool. So the factory maximum gives you 80 degrees. I'm going to take that to 86. Okay, so let's go throttle. Maximum throttle position, 86. Okay, last row, 86. Last row of this one as well, 86. Boom. Okay, may as well just keep going with what we've got here. Maximum intake air, stage 1, don't really need to go above that, let's be honest. We don't have to, because I haven't got any logs yet of this car. I don't really want to change that, so I'm going to leave it as it is, okay? Race start, boost pressure, all that sort of thing. How good is this though, right? We've got pressure up throttle, best response with low fuel quality. So that's like when we have our octane learning, all that sort of stuff, right? Same with here, I think let's have a look if we just got the put SP. No, that is not our octane learning yet. Where is our octane learning? Let's have a look, see if we can find. Yeah, here we go. Boom. Pressure up, throttle set point restricted by knocking. So that's our octane learning there. All right. People usually tune this map. Problem is, if the car is actually knocking, it will also give you full boost if you tune it. So it's up to you whether or not you want to take that risk. I personally don't like doing things like that. I like having the safety functions there to protect the engine. I would say, full honesty, maybe 3 engines have blown in my time. Due to their various reasons, but 3 over 9 years I think is a pretty good statistic when I tune sometimes 20 cars a day, depending on the day. We're going to go ahead and do 2600, which ends up being 1.6 bar. Alright, and we want it to be a pretty much direct XY relationship between the axes and the value in the map. Okay, like I said, I'm not touching the octane learning. I'm not interested in playing with things like that. No one's asked anything yet in the chat. That's okay. Maximum allowed pressure set point. It's not going to reach 2 bar. Maximum allowed air in the cylinder. I'm going to make that to 500. And we're going to, let's just start, I guess, from the top. Minimum MAF threshold for catalytic diagnosis. Again, this probably will never activate again because I've turned it off in variant coding, but it's there anyway. And the maximum is going to be this map here from memory. What's that? 1, 2, 3, 4, 5, 6. That's the maximum there. So the maximum becomes the minimum becomes the maximum, thus never activates. if that's something that you want to do. Let's have a look. I'm pretty sure, yeah, that is the maximum. So there you go. Cool. All right. That's all good. Maximum indicated engine torque deviation. So this basically will be calibrated. Let's go for 500. Minimum allowed engine torque deviation, maximum indicated reference torque. Let's go ahead and tune this map. What a weird looking map that is. Very strange. And you'll notice as well, it goes from 600 RPM to 4,000 after 1,500, and then so it starts limiting it as we get to the top RPM. I'm going to change that to 7,000 and then actually interpolate between the two. Let's try and give us a little bit more control. Kind of want, let's say, 480. Oh no, I'm going to leave that. 500 maybe. Yep, 500. And we'll start bringing it back down again. Maybe go 480 at the end. Something like that. Actually, that looks quite nice. So we'll just keep it there. All right. Just going to go through it and we'll just calibrate it as we need to. Maximum allowed engine torque for gas pedal PVS brake limitation. So when you're pressing the throttle pedal and the brake pedal at the same time, this is the maximum amount of torque that is allowed to be generated during that condition. I'm going to set that to infinity, basically meaning you can brake boost. No comments yet. Pressure ratio at the throttle for substitute pressure upstream throttle calculation. Now this is good for CMOS 18 vehicles, which is the EA888 Gen 3 engine with the Volkswagen Golfs and Audis and all those sorts of things. This map's very good for giving us some additional boost pressure when we need it. For this, it might be just good practice to go something like copy this row here, then go like this, and then go 1,000, right? And we might just go ahead and do a little bit of this. Let's say we want 1.5. Okay, just to give us something a little bit more realistic. Okay, there we go. That looks... I mean, really, we're probably going to have something like that, if I'm honest. The problem is it doesn't... I don't know how well this car is going to receive that. We'll just try something like this for now and see how we go. Calculated turbocharger speed. So what we can actually do is we can set the maximum speed limit above anything in this map, meaning it'll never limit torque based on turbocharger speed. Up to you if you want to do something like that. I don't really recommend doing that, to be honest with you. But what we might do is we might look at our max turbo speed here, max turbo speed. So you've got two maps, right? One's like an upper and lower limit. Usually increasing this by the percentage increase in boost or estimated air volume, or even if you did like a percentage of gain, like 20%, it's still quite a lot. Let's just say if we do go 20%, that gives us the 22. I think 20% is like a realistic thing without us causing any damage. You can also reduce this map as well, and if you wanted to by 20%, it would kind of have the same sort of effect. Okay, increment and decrement of torque limitation depending on turbo speed protection. So this will be a Newton meter value. It's up to you. If you can also set this to 0, and it won't have any effect on your torque limit based on the fact that the turbo speed is getting too high. Another thing as well here is depending on engine speed and I assume intake air temp, we have a maximum turbocharger speed set point. One of the other things we can do here is go 20% increase this map if we want to. I usually don't recommend doing things like just percentage increases, but for the sake of what I'm trying to teach here and trying to show you, yeah, this sort of thing will affect maximum boost pressure, right? So something like that's not going to hurt in these little maps. You know, I'm not bloody percentage increasing ignition tables, so we should be fine. All right, we've got that all done. We've got our maximum engine torque. Now this is a very important map because we can actually calibrate the boost profile and the maximum boost pressure as a function of torque. That's how these Siemens Continental ECUs work as well in the Volkswagen Audi scene. you'll notice that if I go reference indicated engine torque, we have here a load torque relationship between the two here. And as you can imagine, if I, let's say, have a value of 382 Newton meters in here, that's going to be a load limit of 1,100 milligrams per stroke. And as a result, we will get a certain boost pressure because it'll be limited by our mass airflow and torque relationship model here. One of the things that we can do is extrapolate the axes and change the maximum values in the map. Okay, that's one of the things that we can do. So if we were to do something like that, let's say we could just go ahead, change the last, or maybe I might make the last row 1500 and 1250, and then let's say with this last row here, realistically speaking, you might go up about 10%, and you might do something called interpolation like that. Okay, and as an example, okay, so let's see if we go as a percentage. I'm gonna go through all these different ones here, apply the percentage, and then I'm going to take the percentage off, and I'm going to do an interpolation between the left and right hand values. Interpolate left and right. See if that works. No, it's not letting us do it. That's fine. We'll have to do it the old-fashioned way. So we go interpolation, top and bottom. Interpolation, top and bottom. Interpolation, top and bottom. Interpolation, top and bottom. Coming through all these different maps here. And we also have another torque model that we have to change as a result, which is our, I might just keep one of these open, our mass airflow for torque intervention set point, right? So we have here 500 Newton meters, and this here, 500, and you can see that really our set point air mass, it has to be either the same or above what we've got in here. So 1250, our maximum torque at 1250 milligrams per stroke is 412. 1250 is between here. Yeah, that's fine. Okay, so we don't really need to change the other map based on that. Okay, but what we can now do is go torque. Oh my goodness, angry typing. Maximum torque. Run through all this. We have here, as you can see, some of the maps have a torque limitation depending on first gear for a manual gearbox. If you want to remove that, you can. You'll get a lot of wheel spin, but that also, some people like that. They like being able to modulate how much torque the car can make, but just by using the throttle pedal, right? That might be something they want to do. In this particular ECU, the maximum torque is based on, for coolant temperature anyway, and engine speed. So maybe we want to go ahead and have a look at our torque model here. And let's say we want it between 470 and 500, realistically speaking. So that's something that we can do with this. BMWs are calibrated in a very similar way to this torque profile. It's sort of starting high, then it sort of tapers down. Volkswagen, Audi group cars, and Mercedes-Benz, they usually start low, come up, and then come down, sort of like a torque or boost profile. But for this, it's a little bit different. I'm just going to start with something like 450 and do that as an example, and then ending at 378. Negative 15 degrees coolant temp. I probably don't want to give it maximum torque. I'm just going to interpolate it and then interpolate it there as well. So it's kind of a little bit safer. We've got some function protection here. Okay, what have we got here? Oil temp. 140 degrees, pretty hot. I'm going to leave it the same as that. And then we got our maximum indicated engine torque, depending on intake temp. Really, I want to probably tune it to be, let's have a look. Not that one. How many rows we got? We got a few rows. Might go something like this. Okay. once we get to 80 degrees, man, that's getting hot. I'm probably going to start offsetting torque once we get there, you know, just for the safety of it all, you know. And 30 degrees and below, we want a little bit less torque as well. Just, we can give it full load torque, full load and all that, but I don't know, a safety thing, probably not worth it to me for a stage 1. It's not really necessary. Cool. We have indicator. Yep, that's completely limited. That's fine. Right. Manual deactivation of catalytic diagnosis. Yes, we'll do that anyway, even though, like I said, variant coding has already turned it off. Maximum intake air, this is milligrams per stroke. I'm just going to do 2500. Our torque tables, as a result, are going to be the ones that are going to be limiting us. I'm just going to make sure I haven't forgotten any other limiters. Let's have a look and see what's max pressure up throttle. I knew I would have forgotten that. There it is. Okay, so max pressure up throttle for standard conditions. Really, we kind of want to have, let's say 1600, and then we'll sort of taper down to protect the engine. Maybe let's do the 1250 top end, right? Something like that. Our ignition timing now. Look, you can leave it stock for a stage 1 because with the added boost pressure and things like that, we don't really know what the effect is going to be. I would usually also recommend, especially if you don't know fuel quality and things like that, it might be a good idea to actually remove timing out of our base timing, right? It might be a good idea to do that. I know that these cars can take about 24 to 26 degrees of timing on a stage 2. I'd say about 20 degrees on a stage 1. But yeah, it's really up to you. Like for me, it might be just maybe a good place to start. Like, if we go 4 degrees of timing, there we go, like 15, something like that. Just from what I would say would be a good starting point. Probably wouldn't change that. And what I'm going to do is I'm going to go ahead, go to delta, which is the amount of ignition timing I've added. I'm going to copy the delta and then paste it in all the other maps, paste clipboard, and it's going to paste the delta in the other maps too. All right. I know that this car can take that. Obviously, using 95 or 98. Let's have a look and see if he's actually specified. Yeah, nothing to modify and pops and bangs is crazy enough. Yeah, I appreciate that. Stop-start inhibition. Okay, so he wants the start-stop function turned off. All right, so if we go start, stop. Manual activation of start-stop monitoring. Well, yeah, okay, we'll see if manual activation, start-stop monitoring, we'll turn that off. Manual activation of key start monitoring, I'll just do the start-stop. If we go... There's a lot of ways we can do this. We can basically set the boundary conditions in order for it to enable to be crazy. Like let's say minimum temp for stop start, you can make it 200 degrees and it'll never enter stop start as a way to do it. Let's just have a look and see what we can use here. Stop start. Okay. No. Pedal threshold for stop start. That might be a way for us to do it, hey? Pedal threshold for stop start. Okay. So if we make that like 300 or something like that, that should turn off stop start. Stop start. Okay. OC. Maximum engine speed for stop start interruption. No. Okay, I'm not going to touch that. Alright, I think that should be enough really for that. And obviously we've got our boost control now is our last thing that we can work on here. Yeah, that's fine. We're happy with where that is. Okay, he doesn't want us to tune the crackles, which the impulse combustion stays factory. Maximum charge air. Yes, this will need to be tuned. 2750. 50. We'll go to 450. Okay. Now we have our wastegate control signal. Probably a good idea to do that, right? What we will do is, given this boost is going to come on a little bit harder than usual, we usually drop a little bit of the starting to mid-range. Just starting with something like a 5 to 10% drop of the boost actuator, okay? That's usually just a good place to start. It's not going to hurt anyone or anything. And then from there we can calibrate the PID if we need to after that, okay, based on some data logs, right? Okay, so I think that's a pretty good start for everything. Look, we can do some cam timing if we want to. Cam, let's go 2-dimensional. Camshaft position set point. There we go. Alright. Gonna transfer all these maps across. Cool. And we pretty much want full load maps only. So what's this? Part load. We're not really interested in part load at the moment for the cams. Part load, part load. Do we have any not part load ones? Very cold, cold. Pressure high, part load. Pull. Surely there is some that aren't part load. EGR control. Quite a bit here, isn't there? Idle. Full load. Did I just see that? I did just see that. Camshaft position set point. Full load. So that's for cold coolant temp. What I'm going to do, I'm actually just going to type in full load, right? I'm going to go from there. Full load. Coolant temperature high, full load. Yep, cool. Cold, very cold. Coolant temperature level low. Okay. I'm going to just tune the full load. Coolant temperature level low and coolant so temperature high. I'm going to do them. Full load. Here we go. Very cold. I'm not going to touch that. No need to do that in my opinion. Okay, so we have here. Let's see what we've got. Okay. Now, my understanding is that the... let's have a look actually. Let's see what's going on here. We have two very different set of cam tables here. Right, as you can see. Now, I'm just going to make sure that I'm right here. Hyundai I30N BVT exhaust intake. Let's see to make sure that it is BVT in both. BVT. Dual overhead cam, dual continuously variable valve timing. Good, okay. I'm glad I didn't say the wrong thing. So, meaning that the exhaust and intake camshafts are both fully adjustable and controllable with the ECU. You can see the difference here, one being intake and one being exhaust, okay? That is what you're seeing here. So we can go ahead and tune this sort of a thing, and you'll notice the actual, the name of the map is different, okay? IPCam, SPTCOH, F, and then VCP1, and then that is VCP0. So if we wanted to, we could go ahead and tune the cams. Again, probably best done on a dyno. Not really sure if it's worth it necessarily in all cases. Again, I'll probably wait till we get some logs, but for now, I'm just going to save these maps here with flag, and we can get back to these when we need to. Export this, okay, .bin, and then we can go ahead and upload it to the gentleman here, and he can go ahead and get his file. And that's pretty good for us. Does anyone, okay, how would you disable cold start on the ECU? Okay, good question. I'll get through to that now. So for cold start, usually there's a combination of things that need to be changed, right? You've got your fueling at cold start, you've got your camshaft timing at cold start, and you have your ignition timing at cold start. When people say, can we change cold start or disable it, usually they're referring to the cam timing and the fueling. Okay, cam timing, because there's something called the exhaust gas recirculation effect when you have valve overlap between the intake and exhaust cams. This promotes the engine to warm up, but also makes the car louder. You'll notice that when you start a car at cold start, it's louder and it's a bit more deep and everything. That's because of the exhaust gas recirculation effect that you're getting from the cams. Yeah, like I said, there's a fueling change as well. So we go cold start. I don't know even if it would be that simple with this ECU, but correction factor, cold start, logical field, cold start. Some of the ECUs will even just let you turn it off with like a single byte rate. And there might be minimum, maximum temperatures for cold start, right? So what we can do is you can go cold start min, and we can actually look at this and determine what the ECU is referencing as a cold. Okay, specific temperature tolerance for adding compensation threshold in cold start. There might be something around here. Minimum TCO for idle speed diagnosis cold start. Deviation for cold start. Okay. Coolant temperature set point threshold for cold start. Ambient temp for cold start, minimum engine temp for cold start, things like this. So you can change these maps here. And obviously, like I said, with the cam timing, what you could go ahead and do if I was to disable cold start is you would copy the coolant warm maps onto the coolant cold maps. And then that would mean that the camshaft timing and all the other maps for that factor would, run the engine temperature normal state, and then you wouldn't have that exhaust gas recirculation overlap and all that sort of stuff with the valves and everything else. So yeah, is there any more questions before I go? Because I'm going to sort of end this soon. Let me know, chuck it in the chat now. Otherwise I will end it here. I'll give you a little bit. Yeah, like I said, write something in the chat. I'm going to end it soon. If you haven't written any questions in the next minute or so, I'll probably end it here. But I'll give you guys some time to think about some questions that you have.
You fucking beauty. Brake on. Press it once, press it twice, press it 3 times.
All good.
Press it 4 times. 1, 2, 3, 4.
All right, guys, I'm going to head off here. See you later. Thanks for watching.